question? Great. Okay, now here, before we start chapter 5, let me go back to chapter 4, okay? In chapter 4, we talk about the discrete random variable, right? And in chapter 5, we'll be talking about the continuous random variables. So we classified our random variables as a discrete random variable and a continuous random variables. So if we have our random variables, okay, and if they assumes a number, that we can make a list. Those random variables are a discrete random variables. And can you tell me the 3 different ways of representing discrete random variables? How can we represent discrete random variables in 3 different ways? Kayla. Is graph, formula, and a table, right? So we use graph, table, or formula to represent the discrete random variable. So in that graph, what kind of graph do we use for the discrete random variable? Like what is the type of graph that we use to represent our discrete random variable? So we had like a 2 graph, right? So 2 different types of graph. For example, let's consider we have a discrete random variable, and I'm using a table here. So this table has x, okay? And we have p of x. And what is p of x? What does that represent, p of x? Probability of x taking a different number, right? So let's say x takes a number 1. And when x takes a number 1, the probability that x takes a number 1 is, let's say it is 0.5. Okay? Let's take x takes another number 0. And the probability is 1/4. And let's say we have -2 and the probability is 1/4. So this is the table, okay, for our discrete random variable x. Now, in order to graph this discrete random variable, so we have x along our horizontal axis and we have p of x. So vertical axis represent p of x. The horizontal axis represent the values for x, okay? So the values of x is 0, 1, -2. So let's say this is 0, this is -1, sorry, we don't have -1, +1, and this is 2. Now, you can use a histogram or you can draw a vertical line to represent the probability, okay? So let me use a histogram. So when x is equals to 0, the probability is 1/4. So let's say this is 1/4 and this is 1/2. So we have the bar of a height 1/4. Okay, so we have this bar and the height of this bar represents the probability when x is equals to 0. So when x is equals to 1, our probability is 0.5, which is same as 1/2. So we draw a bar of the height 1/2. Okay, and when we have a -2. Let me okay, let me call this is 2, okay, not the -2. Now, so if you have a -2, you have to start from -2, 0, and 1, okay? So when x is equals to 2, the probability is 1/4. So here, this height represents the probability. And this is the histogram. Now, if you have a histogram, what gives you the probability for x? So you have the histogram. Now forget about the table. Now let's consider we don't have this table representing discrete random variable, but we have a graph. We have a histogram that represent a discrete random variable. Now, what helps you to find the probability that x takes these numbers? So how do you know the probability of x when it takes a value 2? the height of a bar, right? So the height of a bar helps us to, or that gives us the probability. Okay, so since we use the p of our vertical axis that represent our p of x, okay, the height is same as the probability here. Now, and the next we also talk about the binomial random variable, right? And the binomial, to be a binomial random variable, we should have like a 4 different specific characteristics. Okay, that's what we had in chapter 4. Now here we'll be talking about continuous random variable. Okay, and this continuous random variable, it can assume any value within some interval or within some intervals. Okay, so we can't make a list of the values that the random variable takes. Okay, that can take any number. Okay, so those types of the random variable is a continuous random variable, and to represent continuous random variable we use a graph. Okay, we use a smooth curve. So let's, for continuous random variable we use a smooth curve. Okay, so we have x on our horizontal axis. Okay, and we have this f of x, and f of x is the function. Okay, it's a probability density function. We'll be talking about this, and this function is the curve. It can be any curve. Okay, so let me call, so we have been using this bell-shaped curve. Okay, so we have this curve, we have this smooth curve, and this smooth curve is the representation for continuous random variable. For the discrete random variable we use a histogram. We also had a table. Okay, or we can use a graph where we have the vertical line to represent the probability. Okay, but for the continuous random variable we will have a curve. It can be this curve, or we can have, okay, let's say you can have the curve that looks like a rectangle. So let's say you have this curve. Okay, or you can have a curve that looks like a rectangle. Okay, so we use a curve, we use a smooth curve to represent the probability, for continuous random variable, and this curve are called the probability density function. Okay, so we have this curve, we can find the function. Okay, we can find the equation to represent this graph. Okay, and those equations are the function. So for continuous random variable we are using smooth curve. Okay, and we call this smooth curve as a density function or frequency function or probability density function. Okay, it's the same thing. So frequency function or density function. Now our target is always finding the probability. Okay, we are looking for the probability. Okay, now if we have a continuous random variable, or if we have a probability density function, so function means if we have these graphs. Okay, so these graphs is the function. Okay, we can find the equation that represent this graph. Okay, so if we have this graph or this function for continuous random variable, then the probability, okay, the probability that x falls between two values. Okay, let me call my two values is a, b. So let's say we have a, we have b. Okay, now the probability that x fall between two values, which is probability that x fall between two values, means greater than small value and less than big value, right? So the probability that x fall between a and b is the area under the curve between a and b. Okay, now let me get rid of these curves, these two curves here. So let's consider we have this curve and we have two values a and b. Now our target is finding the probability that x falls in between a and b. So we want to know what is the probability that x fall between in this region. Okay, and this probability is equals to the area under the curve between a and b. So So we are looking for the probability that x fall in this region. Okay. Now, what portion of the graph will be in this region? How do we find that? So if you just draw a vertical line at A, so let's draw a vertical line at A, and let's draw a vertical line at B. Okay. Bless you. So this region, see this part is in the region AB, right? So we are looking the area under this curve. So not all curve, okay? We are looking the area under this part only. Okay? So we are looking this area. The area under this curve and between A and B. So we want to know the area of this region. And this area is the probability that x fall between A and B. So if you have a continuous random variable, you are always finding the area. And that area is the probability. Okay? If you have a discrete random variable, you are looking at the height of a histogram. You are looking at the height of the vertical line to find the probability. Okay? But if you have a continuous random variable, you are always finding the area under the curve to find the probability. Okay? Now if we have a something different graph, let's say we have a x continuous random variable, we have f of x. Okay, this is the function for the curve, and our curve is, okay, so this is, let me call this is 4, and this is also 4. Now what is the shape of this curve?
Square.
Yes, it's a square, right? So we have this function, and let me call this is 0. Now, so what does it mean by finding the probability that our x is in between 0 and 4? So if you are asked to find the probability that x takes a number between 0 and 4, it means we are looking the area under the curve in between 0 and 4. So we have 0 here, we have 4 here. Okay, so this is our function. Now what is the curve? Okay, this function in between 0 and 4. So we have this region. Okay, so this is the region under this function. So you are looking this area. Okay, so the area of this region is the probability that x takes a value greater than 0 and less than 4. Okay, you are always finding the area under the curve if you are asked to find the probability. Okay, now let's go to an example. So here we have an example. So researchers at the University of Rochester studied the friction that occurs in the paper feeding process. Now, they studied the friction that occurs in the paper feeding process. Now, what kind of number do we get for this experiment? So if you are trying to collect the friction that occurs in paper feeding process, now is this your random variable or discrete or continuous? What kind of values friction takes? Does the friction takes a value 1, 2, 3, 4, 5, 6, 7, or it can take any value? It can take any value, right? So this is our continuous random variable. And if you have a continuous random variable, the finding probability is same as finding the area under the curve. So once you know your random variable is continuous, you should also know that you are finding the area under the curve. Okay, so this is our continuous random variable. Okay, so we have this x, the friction coefficient. Okay, and this is our continuous random variable, and which measures the degree of friction between two sheets of paper. Okay, the random variable can be modeled using the smooth curve. Now this random variable x, which is the friction coefficient, is represented by this curve, and we have our curve in a rectangle shape. Okay, so we call this as a triangular density function. It's a function, it's a density function. Since it has a shape of triangle, it's called triangular density function. Okay, that's the only, but it is a probability density function. So this function, this curve represent our triangular density function. Now our x, okay, which is the coefficient, friction coefficient, it ranges between 5 and 15. Now what does it mean? Can it be possible that x takes a value 0? No, right? Because it does mention that x ranges between 5 and 15. So x can't be less than 5 and greater than 15. Okay, so we have a triangle starting from 5. So from here to from this point. So we have this curve. Okay, this curve is our triangular density function, and we are asked to find the probability that the friction coefficient is less than 10. Okay, now 10 is here, right? So we have this 10, and we want to find the probability that the friction coefficient, which is x, okay, x is the friction coefficient, and we want to find that x is less than 10. So less than 10 means x taking a value greater than 5 and less than 10, right? X can't take a number less than 5. Okay, so 5 is the lowest number that x can take. So we are asked to find the probability that the friction is less than 10. It means the x taking a value greater than 5 and less than 10. Now we are finding the curve under this region. So we are interested in between, we are interested from 5 to 10. From 5 to 10. Now your next target is finding the graph in this region 5 to 10. So what is the portion of graph? So this portion of graph. So we have this portion of graph in between 5 and 10, right? Now our target is finding the area under this graph, under this portion. So we want to know, so it's already highlighted yellow. So that's the region. So we want to find the area of this region, okay? And this area is same as a probability that x takes a number between 5 and 10. So you are finding the area, which is same as the probability. So our target is finding the area of this region rate. Okay? Now, what is the shape of this region? Triangle, right? And how do we find the area of triangle? Now, so we have this triangle. Okay, so the area is, let's find the area. So area is half time base time height of a triangle, right? So we have half. What is the base length? So base, this portion is base. So this is base. So what is this? Do you all agree it's 5? Okay, so we have 5. What is the height? So height is this region. So this is the height. 0.2. Do you all agree? Okay, 0.2. Okay, 0.2. So what is this equals to? 0.5. Okay, 0.5. So this is the area. Now, and this area is same. Okay, so this is also the probability that x takes a number greater than 5 and less than 10, and which is 0.5. So finding the probability is finding the area if it's continuous random variable. Okay, we use this method when we have a continuous random variable. But if you have a discrete, you are looking for the height. Okay, height of the is a bar. But if you have continuous random variable, every time you are finding the area under the curve. Okay. Do you have any question in this example? The only thing I want you to learn is that if you have a continuous random variable, finding probability is same as finding area under the curve. If you understand this part, the remaining should be easier. Okay, now the next year we have the uniform distribution, okay, and this is also a continuous random variable, okay. Uniform distribution is continuous random variable, but the only difference is that the variables that have equally likely outcomes, it means the probability that x taking any number is same for all values of x. If we use the same function, like we had our function triangular, okay, so we had a triangular density function. Let me draw that. So our triangular function, so this was the function. So we had 5, we had 10. So this is this was 0.2, 0.2, 0.1. So this is f of x. Now for this function, can you tell me what is the probability when x takes a value 5? Okay. Okay. 1/5. Okay, this was 15, right? It was 15, and this is 10. Okay. Now, okay, before that, let's do the probability when x takes a value 10. Now, who can tell me the probability that x takes a value 10? And this is a continuous random variable, okay? We are using the same function. Now, what will be the probability that x takes a value 10? 0.2. Okay, now at first this is a continuous random variable. If it was a discrete random variable, yes, you would be correct. We are looking at the height of that point, right? Height at the 10, and the height is 0.2. But this is our continuous random variable. And if we have a continuous random variable, what are we finding? We are finding the area. Now, okay, we are finding the area under the curve at 10. So at 10, so we have this. So what is the curve? What will be the curve looks like at point 10? It's just a point, right? So at 10, we have this point as a part of a curve. Now, what will be the area under that point?
10. So it would be 10 times 0.2.
But how did you multiply? Is that the way to find the area? Now, what we need to find the area? Can you find the area of a straight line? What is the area of a straight line? So at this point, we have this region, and our region is a vertical line. And what will be the area? It is 0. The line does not have the area. If you have any shape, then we do have the area. Like if you have a rectangle, triangle, or a circle, you can find the area. But you have a vertical line, okay? So it does not have area. It means the area is 0. So the probability when x is exactly 10 is 0. Okay, in the similar way, the probability when x is equals to 5 is 0. Okay, and when the probability that x is equals to 15 is 0, because it does not have any area under point. Okay, so if you are asked to find the area when x takes some specific values for a continuous random variable, it is always equals to 0. Okay, if you have a continuous random variable, that's the condition here. If you have a continuous random variable, and if you are asked to find the area that x takes some specific value, then it is always 0. But if it was a discrete random variable, yes, it will be height of a bar. It will be 0.2 if it was discrete random variable. Okay, now so here So we find the probability that, okay, we had the probability that x takes a number greater than 5 and less than 10. We had a 0.5, right? Okay. Now, in the uniform distribution, okay, we have the graph. Okay, now let's consider we have this graph. We have f of x, and let's take this graph. And let me call this is A, this is B. Now, in this picture, what is the height of a graph at A and B? How they are related, the height of a graph at A and B? They are same, right? But in our triangular density function, what is the height of our x at, what is the height of our function at 5 and 10? Are they same? The height of our function at 5 is 0 and the height of a function at 10 is 0.2, right? But in this function, the height is same, okay? It means that we have the equally likely outcomes in for this function. And if we have this function, this kind of function, we call it uniform distribution, okay? So this is our uniform distribution. The height of a function remains same for all x values. You have a graph, and in that graph, the height of a function is same for all x values, then it is uniform distribution. Okay, and if the height of a function is not same, that is continuous random variable. And this is also continuous random variable, okay? Uniform distribution is a specific type of continuous random variable. So both of these are continuous random variable. Okay, the difference is that in our triangular density function, the height of a function is not same, but in this, let me call this a rectangular density function. In this rectangular density function, the height of a function is same. And if you have a function with the same height for all x values, we call it uniform distribution. Okay. Now, if you have a uniform distribution, and you will be given, okay, you are not required to find whether the function is uniform or not. It will be mentioned on the problem. It will mention you that the continuous random variable is uniform. So if you have a uniform, then you will be using these formulas here. Okay. So if we have a uniform random variable, the probability function, okay, f of x is 1 over d minus c. Okay, so here so for example, let me draw a new graph, okay, new uniform random distribution, so that we will know what is c and d. So let's say we have this x, this is f of x, and we have this rectangle. Okay, so the rectangle, the graph is starting from C, okay, ending at D. A is any point in between C and D, and B is also any point in between C and D. Okay, so C is the point where your graph is starting. Okay, so our graph is, this is the graph. So this horizontal line is our graph. Okay, so we have this horizontal line graph. This graph is starting at C and ending at D. A and B are any point in between C and D. Okay. Now, if we have this uniform random distribution, then the f of x is 1 over d minus c. Now, what does f of x give us? Why we want to find f of x? So what does it give us? So if we have f of x means we have a f of x is a function. So if we have a function, we can have a graph. Okay, so if once you have your f of x, then only you can draw the graph. Okay, then only you can draw this graph. Without f of x, you can't draw the graph. So finding f of x means you are finding the shape of a graph. Okay, so you should know how to find the function. So finding function, once you find the function, you plot that function Okay, you find the graph of that function, and once you have the graph of a function, you can tell whether the random variable is uniform or not. Okay, so f of x is simply equals to 1 over d minus c, and make sure your c is the starting point for the function, okay, and d is the ending point for the function. The mu is the mean, okay, or expected value. This expected value is the average of c and d. So c plus d divided by 2 is the mean. The standard deviation is d minus c divided by square root of 12, okay, and the probability that x takes any number between a and b is b minus a divided by d minus c. These formulas will be given to you, but you should know where to use. You use this formula only when we have what kind of distribution? Uniform distribution, and that uniform will be given, keyword will be given to a problem. So if you have a problem where you see a uniform distribution, you are using these formulas to find the function, mean, standard deviation, and the probability. Okay, now let's take an example. So we have this example. Okay, on your handout you don't have enough space, so you can use the last page. Okay, so I have a blank left, and if you can, so we have like a 3 different problems. So if you need more space, you will need more space for this example, so you can use the last page. Okay, now so here we have an unprincipled used car dealer sells a car to an unsuspecting buyer, even though the dealer knows that the car will have a major breakdown within the next 6 months. So we have a used car dealer, and the used car dealer is selling a car that will have a major breakdown within the next 6 months. The dealer provides warranty of 45 days. Okay, he knows that the car will have a major breakdown within next 6 months, but still the used car dealer is selling a car. Okay, and he gives a warranty of 45 days on all cars sold. Let x represents the length of time. So x represents length of time. Now the very first question, is your x discrete or continuous? Now length of time is, now what kind of number does length of time takes? Can you make a list of that number, or it can take any number? It can take any number, right? So here our x is the continuous random variable. Assume that x is a uniform random variable. See, it does mention that. Now our x is a uniform random variable, means you're going to use these formulas. Okay, so make sure you have this uniform word before you apply these formulas. Okay, so x represents a uniform random variable with values between 0 and 6. Okay, now so our x takes a value between 0 and 6. So we need a graph also. So on the horizontal axis, you're going to have x, and on the vertical axis, you're going to have f of x, not the p of x, okay? For the discrete random variable, you're going to have p of x along the vertical axis. But for the continuous random variable, you have f of x. F of x is the shape, is the graph, okay? It gives us the shape of the graph. So your x takes a number from 0 to 6. So we have 0 here. So 1, 2, 3, 4, 5, 6. Okay, now we don't know, what we know is going to be a uniform, but we don't know where to draw the horizontal line. Okay, we need to find that. So since your x has a values from 0 to 6, now what is this 0 and what is this 6? We need to know what is A, B, C, D here.
In the months.
Now, so we have 0 months. Now, what do we use to represent this 0 out of this A, B, C, D? Now, we have this figure to compare. So, what will be C? Yes, so our C is 0. And what is our D? 6. So, this is D. Now, the very first question is, calculate and interpret the mean and standard deviation. Okay, so for A, we are asked to find mean, which is mu, and mu is C plus D divided by 2. C plus D divided by 2. Our C is 0, D is 6 divided by 2, and 3. So 3 months is the mu, okay, because X represents the length of time, okay, and it is in terms of months. So we have mu as a 3 months, and this is the average value. It is the average length of time, okay, until the breakdown is 3 months. And we are asked to find the standard deviation. So sigma is, what is the formula? D minus C divided by square root of 12. So our D is 6 minus 0 divided by square root of 12, and we get 1.73 months. 1.73 months. So this is our standard deviation, okay. In the next, now do you have any question for part A, finding the mean and standard deviation? Once you know your C and D, you substitute on the formulas, okay. Now for number B, we are asked to graph the probability distribution of X. So we need to have a graph, and to find the graph we need to know what is f of X. So we need to find the function. So what is our f of X for uniform distribution? It is 1 over D minus C. It is 1 over D minus C. 1 over D is 6 minus 0, which is 1 over 6. So f of X equals to 1 over 6. Now how do we draw a graph for this function? We have f of X equals to 1 over 6. Now how do we draw a graph for this function? What kind of graph do we get if we have a function like this, f of X equals to 1 over 6? What would be the shape of a graph for this kind of a function? How do you graph f of X equals to 1 over 6? No.
The line is 1/16.
So you have a function. What is the type of this function? Is it constant, linear, quadratic, cubic, exponential? What kind of function is this? I forget about uniform. Let's go back to college algebra. Okay, it's a linear function, and if you be a more specific, now is it a constant or a, so linear function what is the shape of a graph for a linear function? It's a any line, right? Straight line. So that is our linear function, and this is also a line, but we have our f of X equals to 1/6. This is our constant function, and if you have a constant function, then we get a horizontal line. So if you draw a graph for this function, we have a horizontal line at 1/6. Okay, let's say this is 1/6. So you draw a horizontal line, okay, at 1/6. Now your graph is starting at 0. Now how far you draw this horizontal line? How far? Up. Yes, because this function takes a value between 0 and 6. So you are starting at 0, okay, and you are ending at 6. So this is the graph for this function, for this uniform distribution function. Okay, now what is our next question? So that the mean on a horizontal axis, okay, now let's show the mean on our horizontal axis. Mean is 3 months, okay. So this is our mu, right? That's enough. It asks us to show our mean in the horizontal axis. 3 is the mean. What is the next question? Also, show 1 and 2 standard deviation intervals around the mean. Now, let's find 1 standard deviation interval and 2 standard deviation interval. So, how do we find 1 standard deviation interval? 1 standard deviation interval. What does it mean? How do we find this? This is, so you are subtracting 1 standard deviation from the mean and adding, right? So you have a mu minus sigma to mu plus sigma. So this is our one standard deviation interval. Okay. Now in the similar way, what would be two standard deviation interval? It will be mu minus, you are subtracting 2 standard deviation, 2 times standard deviation, and you are adding 2 times standard deviation. So this is 2 standard deviation interval. Now in the similar way, can you write 3 standard deviation interval? And this would be mu minus 3 sigma, 2 mu plus 3 sigma. And we had these intervals earlier, okay, it's the same. Now let's find these intervals. How do we find? We know mu, we know sigma, we substitute. So our mu is 3 minus sigma is 1.73. Minus 1.73 to 3 plus 1.73. And this is equals to, can you give me a fine? So 3 minus 1.73, what is that? What is 3 minus 1.73? 1.227, okay. To 3 plus 1.73 is 4.73. So this is one standard deviation interval, okay. In the similar way, you can find 2 standard deviation intervals. So mu is 3 minus 2 times sigma. Sigma is 1.73. 2 mu is 3 plus 2 times 1.73. 1.73. And this is negative 4. Sorry, you said 0.4.
Yep.
So negative 0.46 to
6.46.
oh 6.4. Is that 6.46? Okay, so this is the 2 standard deviation interval, and in the similar way you can find 3 standard deviation interval, right? Once you have the mu and sigma. Okay, now we are done for part B. Now let's see what we have in number 3. So in number 3, you are asked to find the probability. Now this is our continuous random variable. Finding probability means we are finding. So this is continuous random variable. Finding probability means we are finding area. Don't forget that. So find the probability that the breakdown occurs while the car is still under warranty. Now we need to find the probability that breakdown occurs while the car is still under warranty. Now what does it mean by under warranty? What is the timeline? 45 days. Now how can you tell that in terms of x, the values of x? Our x takes values from 0 to 6. But we have we don't have a 45 days here. Yes, our x is in terms of months, okay? So what does it mean by 45 days in months? It is 1.5 months, right? So we are looking at the 1.5 is somewhere here. So we have this 1.5 here. So we want to find the probability that car is still under warranty. It means what portion, now what is the region? So what is the part of our graph we are interested in? So under warranty means under 1.5, less than 1.5, right? So less than 1.5 means the graph, so we have this graph starting from 0, okay, all the way up to 1.5. And we want to find the area under this graph, and this is the area, this is the region, okay? We want to know the area of this region. So we want to know area of this region. See you are finding the area of this shaded region. Once you have your graph, okay, you are looking at the area under that portion only, okay? You are not finding the graph area for under whole graph. You have to find the specific region, okay? and you are looking at the area. Now, what is the shape of this shaded region? What is the shape of this shaded region? Rectangle, right? And we know how to find the area of the rectangle. So for number C, how do we write this probability? Like, how do we represent this in a notation? Okay, probability that x is greater than 0 and less than 1.5. Okay, and this is area of this rectangle. And the area of this rectangle is, how do we find the area of the rectangle? So we want to know the length and the width. Okay, now what is the length of this? Okay, we can just call this is our length. Okay, now what is this length? 1/6, right? So we have 1/6 time. Now what is this shortest length for this shortest side? What is this? 1.5. Okay, 1.5. And 1/6 times 1.5 is 0.25. And this is the probability that the car, the breakdown occurs under the warranty, 0.05. So finding probability is finding area under the graph. And we use this only if we have a continuous random variable. Okay. All right. Let's do this much for today. Okay. Remaining we'll do in our next class. And if you have any questions,